reactivity depends on the electrons in the electron cloud. Remember that an atom has its protons and neutrons tightly bound in the nucleus of the atom. The electrons orbit in the electron cloud. All atoms want their outer energy level to be full. Remember from the last lesson that ionic bonding involves the transfer of electrons from one ion to another. In this lesson, you'll learn how covalent bonds allow atoms to share electrons in order to fill their outer orbitals. Water is a molecule that contains covalent bonds. Let's examine how the oxygen atom and the two hydrogen atoms share electrons to form H2O. You can see that oxygen has 6 electrons in its outer orbital. This second orbital can hold up to 8 electrons, and so oxygen wants 2 more electrons in order to make that orbital full. Hydrogen has only 1 electron in its outer orbital. That first orbital can hold up to 2 electrons, and so hydrogen wants 1 more electron in order to be happy. The solution is for oxygen to share electrons with 2 hydrogen atoms. You can see that this oxygen atom in the center is sharing 1 pair of electrons with 1 hydrogen on the right-hand side and a second pair of electrons with the hydrogen on the left-hand side. Oxygen now has 8 electrons in its outer orbital. The hydrogen on the right has 2 electrons in its outer orbital, and the hydrogen on the left has 2 electrons in its outer orbital. All of these atoms are happy because their outer energy level, or orbital, is full. This sharing of electrons is what makes a covalent bond. Sharing is caring, and caring is covalent. Covalent bonds are often represented by a short line between the atoms. When an atom shares 1 pair of electrons with another atom, this is called a single covalent bond. A single covalent bond is represented by a single line between the atoms, as shown here in this molecule of methane. You also saw those single covalent bonds in the water molecules that we just discussed. When an atom shares 2 pairs of electrons, this is called a double bond. Double bonds are represented by 2 short lines between the atoms in a molecule. Double bonds are stronger than single bonds. Triple bonds form when 2 atoms share 3 pairs of electrons. A triple bond is shown with 3 short lines between the atoms and are the strongest bonds of all. A carbon atom has 4 electrons in its outer orbital. It wants 8 electrons to fill that second orbital, and so it's able to make 4 covalent bonds with other atoms. This makes carbon a very important atom to life because it forms the backbone of all organic molecules. Let's use a simple compound called methane in order to show how carbon can form 4 covalent bonds with other atoms. Carbon can share electrons with 4 hydrogen atoms. These 4 pairs of shared electrons allow carbon to fill its outer energy level, and each of the hydrogen atoms to fill its outer energy level. Organic compounds are the compounds that make up living things. Because of the 4 electrons in the outer energy level of carbon, carbon is the bioelement that all organic compounds are built around. The 4 covalent bonds that carbon can form allow it to make a number of differently shaped molecules that are all essential for life.